All right, still in chapter 16. Here's a problem where I've given you three molecules, A, B, and C. They're all octatriene. And I've asked you how many, let's say just for compound A, how many pi molecular orbitals are there, how many pi star molecular orbitals are there, and how many pi electrons are there. And then I want you to rank A, B, and C by the longest lambda max. All right, so go ahead and hit pause, and then come back. Okay, let's do this question first. How many pi MOs, pi star MOs, and pi electrons? And so for this, from the structure, like I know those PowerPoint shows and the books, there's a lot of complicated stuff about molecular orbitals. But from the Lewis structure, it boils down to this. Each pi bond, right, and a pi bond is always going to be a double bond here. So this double bond has a sigma bond and a pi bond, or it could be a sigma and a pi. We don't differentiate them. We don't differentiate them in the line structure. The other thing to keep in mind is a sigma bond is about 40 to 50% stronger than a pi bond. Okay, so that sigma bond is much more stable than the pi bond. So if this alkene reacts, it's the pi electrons that are going to react. All right, so we have three pi bonds. This has to equal 3 pi bonding MOs. Right? And a pi bond is 2 electrons. 2 electrons there, 2 electrons there, and 2 electrons there. So 3 bonds times 2 electrons. This is 6 pi electrons. And then finally, how many pi antibonding orbitals are there? Let me write this out a little better. Pi star, which is an antibonding orbital, the number of these, that's number, not hashtag, the number of those equals the number of pi bonding orbitals. And in this case, that's 3 as well. All right? But there are, in a stable molecule like this, 0 pi star, no, not pi star MOs, pi star electrons. All right? So in a stable closed shell molecule, there are no electrons in the pi antibonding orbitals. Okay, so if you didn't do it already, hit pause and rank A, B, and C by longest lambda max. Okay, now that you're back, or maybe you had it already. This question, we're basically looking for the longest pi conjugation. Okay, so A, 2 conjugated pi bonds. B, 3 conjugated pi bonds. C has none. Okay, so again, a conjugated pi bond is a pi bond where the 2 pi bonds are separated by a single sigma bond, right? So right here, pi bond, sigma bond, pi bond. If we think about a pi bond as being 2p orbitals separated by a sigma bond, then that criteria also exists for the sigma bond between those 2 conjugated pi bonds. Here it doesn't. We have p, p, no p there, and then p, right? So these 2p orbitals don't have overlap to form a pi bond. Okay, so the longest would be B greater than A greater than C. And what that means is B would absorb light farther to the red than A would absorb light farther to the red than C.